Hi, my name is Leo. Today I'm going to share my experience of modularizing a big-scale app like Line Messenger app. So here's the agenda. First, I will talk about the background of the Line Messenger app, and I will talk about the Android modularization and how do we approach Android modularization in the Line Messenger app. And then I will talk about the best practices that I find is useful so far. And after that, I will give an implementation example for the best practices. So, Line began with a free test messenger app with a free calls and stickers feature in 2011, and then there are more and more features I added, such as home timeline, video calls, and Line premium calls, etc. There are more and more features inside the messenger app. So let me show you the project status for last year in Line Android project. We had 1.4 million lines of source code, and we have 33 modules. There were more than 100 developers who were working on the same project at the main repository. So that's the issue for the last year's structure, which is we have more than 66% of the code is in the app module. Having such a big, fat app module, it makes the app bigger. Like we have 248 megabytes for our Line Messenger app, and the build time is low. It takes around 17 minutes for the clean build without any remote cache, with a very fast machine, and it's unreadable. That's why last year we decided to modularize the app module. And after 1 year of hard work, here's our result. We have 20 new modules are created, and 0.27 million lines of source code are created in separate modules, not in the app module. And the most importantly, we decreased the proportion of the source code at the app module from 66% to 56%. So now I'm going to briefly talk about the Android modularization and how do we approach it in our Line Android project. In a modularized app project, we should only have one application module, but we can have multiple library and feature modules. For the library module, there are two types. The first one is Android library module, and the second one is pure Java or Kotlin library module. The only difference between them is one has the Android framework dependency, but the other one doesn't have it. So to modularize an application, we need to create multiple library and feature modules. And next slide, I will talk about what are the differences between them. So first, library module. It's a standalone module. It can be reused by the other apps, and is for library development. It can improve the build time if we have more modules. It can have the benefits of the parallel Gradle build features. For the dynamic feature modules, it's slightly different from the library module. It's not designed for reusable. It depends on the application module, and it can delay the delivery. It's also improved the build time. The most importantly is we can reduce the APK size by delivering the necessary features to the user. So next, I will talk about how do we approach the modularization in Line Android project. There are two approaches that we used. The first one is top-down approach, and the second one is bottom-up approach. So let's talk about the top-down approach first. For top-down approach, we use library modules, and we split the independent utility classes or library classes from the app module to the library module. And usually it requires lots of refactoring work. To help you better understand it, I will show you the class diagram and the steps how we modularize the application module with the top-down approach. So this is the class diagram. Inside the application module, there are many classes depends on each other. And for top-down approach, we will first create a library module, and then we focus the higher hierarchy, the independent utility and library classes. And then we move those classes to the library module. Because those classes are usually used by many different features, so we usually need to refactor lots of code and the scope of the impact is quite big. Next, I'm going to talk about the bottom-up approach. Instead of using the library module, we use dynamic feature module for the bottom-up approach. Here we will split the features depending on the app module, and it can minimize the affected code. So this is the same class diagram, but instead of focusing on the top left corner, we focus on the bottom right corner, which is the feature-related classes. And here we will create a dynamic feature module instead of library module. And then we move those classes to the dynamic feature module. Because we only focus on one feature each time for the bottom-up approach, so the scope of impact is small. So here are the difference between the top-down approach and bottom-up approach. First, the top-down approach, which is using the library module, it cannot access the app module. But the bottom-up approach can access them. The dynamic feature module can access the app module. That's why the refactoring cost at top-down approach is usually higher, and side effects is larger. So when you see the chart, you think, oh, maybe dynamic feature module is better than a library module. We should use it more. It's not true, because there are some disadvantages of the dynamic feature module. So there are main 4 areas. First is the performance. If we have more than 50 installed features on a single device, will lead to the performance issue. And if we have more than 10 removable install time delivery modules, it will increase the download and install time. So next is the testability. To test the on-demand delivery feature, it requires you to upload the app bundle to the Google Developer Console, and it takes pretty long time. There are still many known issues, such as the data binding issue and unit testing issue. I will talk about some of the issues later in the best practice part. And the last area is the dependency structure. Because dynamic feature module depends on application module, it gives some unnecessary dependency. So it could, the developer can make some mistake by creating some high coupling and low cohesion code. It's hard to maintain later works. So we should only apply the dynamic feature module when it's necessary. Before we create dynamic feature module or library module, there are 3 questions that we should ask ourselves first. This is the decision making in Flowchart. So the first question is your feature requires on-demand delivery? Is it require instant delivery? Or if it's based on the device configuration? If none of them applies to your feature, then you should create a library module instead. So next, I will talk about the best practice. There are 5 best practices I found which is very useful to follow while I applying the dynamic feature module in the Line Android project. I will go through them one by one. So first, we should use the service locator to resolve the dependency challenges between the app module and dynamic feature module. Because app module cannot access dynamic feature module classes directly, we need to use Reflection API to resolve the problem. In Line Android project, we used Leech component library to resolve the problem. Last year, Oishi-san gave a very good talk about how to use the library in different use cases. Resolving the dependency issues between app module and dynamic feature module is one of the use cases you should check out. So this slide I copied from the talk, and this slide shows the concept of how Leech component library resolves the dependencies. First, we create a service provider interface, which named the full facade here. And then we create a full facade implementation class in the dynamic feature module as a service provider. And the Leech component library will use the service loader API to create the instance and load it into the cache. So I will show you the actual implementation. Here is the feature 1 facade. Is the first service provider interface. In this interface, we have one function, go to feature 1. It's used for enter the feature 1 activity. And at the bottom part here, is to lazily load the service provider implementation and put it inside in an internal cache. So this is how the service provider implementation class looks like. It's inside the dynamic feature module. This implements the service provider interface, and it contains the actual business logic. It also implements the service loader components interface, which allows the leech components library to discover this service provider and load it into the cache. And then we also use the auto service library to generate a provider configuration file automatically. This is how we call the service provider interface in the main activity in the app module. We obtain the feature 1 facade components lazily using the extension function, context.components function here. And then we can simply call the function go to feature 1 using the property. Using the surface locator pattern, we can create many facade interfaces for different features. And then we can access the feature module from the other feature module by calling the facade interface in the app module. Using the leech component library, we can also achieve the type safety while accessing the dynamic feature module from the app module. Next, I'm going to talk about data binding issue in the dynamic feature module. So while we applying the data binding to the dynamic feature module, sometimes you'll get some weird null pointer exception after if you have a obfuscation enabled build APK. So we dig deeper in the auto-generated classes by the data binding library. Inside the app module, we find that the root code is from this data binder mapper implementation class. Inside the data binder implementation class, there are many app mapper functions. And this app mapper function is trying to add different data binder mapper classes within different dynamic feature module using reflection API. Because after the obfuscation, all the classes name will be changed. So a null pointer exception will be thrown when we try to inflate the wheel. The second practice is to so the solution of this problem is to set a program rule to explicitly keep all the data binder mapper classes name. Next one, I'm going to talk about the resources. We usually have many resources files inside different modules, and sometimes they will share the same file name. And then we'll have like some compilation error, like on the feature. Base module and inline module, inline live module, they contains the entry fragment closed enter .xml file with different content. To resolve the resources conflicts, we should decide the conventions to avoid those resource ID conflicts. There's a two-way. The first one is to add the module name prefix to each resources ID. The second one is to create a common resources library, and we put all the resources file inside that. Next, I'm going to talk about the library version and issue. In a multi-module application, we sometimes share the same library in different features. It's quite common that we will have different library version configuration, and this could lead some compilation error because some feature might use some of the function which only exists at the old library. To resolve this library version conflicts, we should manage all the library version at the root directory, like the picture. So last practice is to separate the interface and implementation at the different module. There are three benefits. First one is to restrict the unnecessary dependency. And second one, we can easily converge the dynamic feature module to Android library module. And the third one, we can reuse the feature after we convert it to the library module. So I will show you here is the dependency graphs for both dynamic feature module and Android library module. As you can see at the bottom, the interface module basically has the same dependency graph. They both have the implementation module and app module dependencies. Because of this structure, we can easily converge the dynamic feature module to the Android library module without much extra coding by just changing the dependency graph. So I will show you some implementation example how to achieve that. Here's the project structure looks like. We have 3 modules. The first one is the app module, which is the application module. Second one is the feature 1 module. Feature 1 module is the dynamic feature module. And we have the last one is the feature 1 contract, which is the implementation module, the interface module. So let's check the app module. As you can see here, in the app module, it has the feature 1 contract module dependency. And it depends on the it has the feature 1 module dependency, and it depends on the feature 1 and contract module. For the main activity classes, it's the same why I showed you earlier. It obtains the feature 1 facade component and call code to feature 1 function. However, there's a little bit difference between before. We defined the feature 1 facade interface in the feature 1 contract module instead of in the app module. Let's dive into the module and see the dependency graph. So in the interface module, we don't have the implementation module nor the app module dependency. This can restrict the unnecessary dependency while we define the features API. At last, the feature 1 facade implementation class is inside the implementation module, the dynamic feature module. Let's go in to see the dependency graph. And this dynamic feature module, it depends on both application module and also interface module. And the feature 1 facade implementation class is also the same that I showed you before. So this is how the whole project structure looks like. To summarize the whole today's topic, we should modularize our apps as soon as possible, because the later we modularize it, the more complex of the dependency graph it will be. Second, we should only apply the dynamic feature modules when it's necessary. The last point is to avoid using any classes or resources from the app module in your feature module. The reason is because if we have extra dependency, it's easy for the developers to make some mistakes to create some high coupling and low cohesion code. It's hard to maintain the code afterwards. So that's the end of today's talk, but there are 2 more talks from linedevday. It's also very good, useful for you when you apply your dynamic feature module in your project. The first one is sharing experience of adapting app bundle on Line Android CI from Yongcha-san. It will talk about how do we adapt the dynamic feature module on the CI. And the second talk is enforcing code convention with lints from Danielson. And he will talk about how do we use lints to maintain the code health for your modular app project. For example, there are some convention that we can apply using the lints. And yeah, that's it for today. Thank you very much.